drenching ourselves in the limitlessness of the universe. We people have consistently scrutinized the chance of whether we truly are the main species to have at a planet, looking at the stars, mulling over far-off worlds, and investigating the potential for life past our little blue planet. That potential has at last appeared. NASA's chief has simply declared that the James Webb Space Telescope has caught something phenomenal at the edge of our inestimable neighborhood. The James Telescope has won no mark on Proxima B, the nearest possibly tenable exoplanet to Earth. We reviewed that a potential city-made by canny life had been identified, which to date we don't have the foggiest idea about. The new James Webb revelation shows how the splendor of the counterfeit lights of the city of Proxima B has expanded in expansion. The synthetic piece of the environment of this exoplanet has been found. So go along with us to this staggering excursion to Proxima B to find the subtleties of this revelation as indicated by NASA's chief. The Webb telescope may have utilized this innovation successfully and has distinguished life on Proxima B, an exoplanet found simply 4.24 light a long time from our sun-powered planet. General B has turned into a peculiarity of distinction because of its capability to be Proxima B tenable. This exoplanet circles its pairing star Proxima Centauri, a red bantam that is a lot more modest and cooler than our sun, found in 2016. Proxima B lies in the star's tenable zone, otherwise called the Gillick zone, which is the district around the star where conditions could permit the presence of fluid water, an essential element for life as far as we might be concerned. Proxima's monster vicinity to Earth and its area inside the tenable zone has produced tremendous interest and theory about its capacity to help life. Anyway, it means a lot to keep in mind that the livability of an exoplanet is a mind-boggling puzzle, including various elements. Proxima B is characterized tenability as an exoplanet with a mass around 1.3 times that of the Earth and has an orbital time of around 11.2 Earth dates, meaning that it finishes one circle around Proxima Centauri in that time. Anyway, things are not quite so basic as we might suspect. The way that the planet is Earth-like in size and circles a red diminutive person doesn't ensure that it is a careful imitation of our reality and that we can all move there. The tenability of Proxima B is not entirely set in stone by numerous elements. One of them is a planet's air, which acts as a defensive safeguard and plays a critical job in managing temperature. Also, life overall. Anyway, the specific organization of Proxima B's environment is as yet unclear, making it challenging to most certainly decide its tenability. James Webb Telescope researchers are dealing with technique to concentrate on the climate of General B, and a critical device in this cycle is the James Webb Space Telescope. This telescope will permit researchers to examine the light that goes through the exoplanet's environment during travels, which will give them data about phantom attributes and assist them with looking for conceivable biomarker particles that could show the presence of life. Another significant element influencing tenability is the presence of water. In spite of the fact that Proxima B is inside the livable zone, it is significant to decide if it has an adequate measure of water to be considered reasonable for life. Water is a basic piece of the riddle, and researchers are searching for indications of fluid water in the world's surface, whether as seas, lakes, or waterways. These pieces of information could be vital to evaluating the chance of tenability on General B. The presence of water in different states like ice or fume. It is additionally considered on the grounds that water accessibility is fundamental to support organic cycles and is considered a vital mark of tenability. The presence of Proxima B brings up issue about its environment. Researchers should likewise explore factors, for example, temperature, pressure, and land action on Proxima B to evaluate whether the planet is inside a appropriate reach for life to flourish. Outrageous circumstances like a singing intensity or outrageous virus can make endurance. Environment. Troublesome stable capacity is additionally urgent. Volcanic ejections or seismic movement can disturb tenability, however steadiness is a decent sign. Proxima B is accepted to be in a flowing locked state, truly intending that one side of the planet remains for all time in obscurity while the other side is for all time enlightened by the star. The star contrast between enlightened dull sight could create temperature varieties and elements that could influence the planet's tenability. These are only some angle that researchers are thinking about in the look for livable planets. Researchers are exploring the synthetic structure of Proxima Faye to examine the presence of natural mixtures, for example, amino-corrosive and different atoms fundamental for life. They are additionally analyzing whether the planet gets sufficient energy from the star or different sources to fuel natural cycles and permit life forms to develop, duplicate, and flourish anyway. Regardless of this large number of studies, the inquiry emerges with regards to whether Proxima B, as a matter of fact, has every one of the important components to be viewed as a livable planet. Is there substantial proof for this? Well, the revelation of Proxima B in 2016 was an amazing accomplishment. Space experts utilized the high-accuracy instrument called the High-Exactness Radio Speed Planet Searcher, or HARPS for short, to identify the unpretentious gravitational T of an exoplanet around Proxima's T, our closest adjoining star. This high-accuracy spectrograph is planned explicitly to identify exoplanets and works at the La Observatory in Chile. It has been urgent in the revelation of various exoplanets, including Proxima B. The HARPS instrument works utilizing the radium speed technique, otherwise called the DLR spectroscopy procedure. Its capability is to identify exoplanets by estimating the unobtrusive changes in the star range brought about by the gravitational shaft of an circling planet. These movements, known as radio speed or Doppler impact, happen due to the slight wobble of the star as it is hauled by the gravitational association with its buddy planet. HARPS. HARPS has an optical fiber that gathers the lights from the objective star and guides it to the inward spectrograph. Inside the spectrograph, the light is scattered into its various frequencies, permitting stargazers to concentrate on the star's range exhaustively. Along these lines, researchers can decide the star's radio speed with extraordinary precision to accomplish the elevated degree of accuracy expected for exoplanet. Ion HARPS utilizes advances and methods that incorporate a temperature-controlled climate. This permitted balancing out the instrument. What's more, limiting the impacts of smell varieties that could disrupt exact estimations. What is your take about Proxima B? Do you think it is tenable, and that later on we will have the option to move to this astounding since time remembrance? Humankind has inquired itself, an inquiry that stirs perfect interest. What lies past what we understand, what exists past the constraints of our universe? The response is incredibly muddled at this point. The James Webb Space Telescope had found something gigantic and entranced in the far compasses of the universe that could progressive material science. What precisely has a James W. found at the edge of the universe? For what reason are researchers so energized? We welcome you to go along with us to investigate how this telescope has found something enormous at the constraints of what we can notice, assuming that you're keen on keeping fully informed regarding news from the universe. Also, its environmental factors buy into our Channel, make certain to like this video and turn on the notice chime. Albert Einstein's fostered the hypothesis of gravity that reformed Newton hypothesis, and 1916 he applied it to the universe. This hypothesis showed that the universe couldn't tolerate stilling and should be moving, spending, or contracting. In 1929, the space expert Adrian Hubble seen that the cosmic systems were moving away because of the huge explosion. This is the extension of the universe, where the distance between cosmic systems is continually expanding. And hypothesis can, without much of a stretch, make sense of an endlessly extend the universe, or one that revile back on itself like the outer layer of a ball in a higher aspect. Some contend that the universe has an edge since it was brought into the world in the large band quite a while back. Consequently, we can notice systems whose life has voyaged a distance in under 1,382 billion years to contact us, framing a spatial circle fixated on Earth called the noticeable universe. As a general rule, the universe is 92 billion light-years across, and the constraint of the detectable universe is the infinite skyline comparable to the skyline of the ocean, and we know that there are an endless number of universes past it. However, their light has not yet contacted us. Can James cleared space telescopes to the edge of the universe, being multiple times more remarkable than Hubble. It can distinguish the thinest infrared light from the earliest worlds in the universe, as well as planets and other stars in their tenability. Anyway, we don't yet have the foggiest idea what the telescope will see when it's pointed towards the edge of the universe. The universe is separated into the discernible and the inconspicuous, with the detectable being all that we can see by recognizing radiation with our eyes, and the constraint of the recognizable being the astronomical microwave foundation that was delivered 13.8 quite a while back. Around then, the universe was murky like a thick haze. A few specialists accept that there are gravitational waves and neutrinos coming from much more far-off places, despite the fact that this can't be confirmed because of the need of innovation. Cosmologists propose that to all the more likely figure out the universe, one should think about that what we notice is just a little piece of a bigger reality. Finding worlds like a Bell 2744Y1, which lies at the farthest edge of the universe, can assist us with better comprehension this reality, albeit this system is so far away that it requires 13 billion years to contact us. Researchers can notice it in this adolescent exactly a long time back. The Spitzer Tundra and Hubble telescope cooperate to find this system, as each utilizations various pieces of the electromagnetic range to catch information. By joining information from each of the three telescope, cosmologists can look at worlds that really depend on multiple times farther away that any telescope would be able have seen on its own. Stargazers from the Astronomy Organization in Canada's and the College of Al Laguna utilized the H Space Telescope to find the cosmic system Able 2744Y1 and computes its distance and number of stars utilizing Spitzer gear. They likewise utilize a gravitational lensing method, which is like an amplifying impact that shines light from far off systems through worlds closer to Earth. The cosmic system is little contrasted with our Milky Way, with a width of about 2,300 light-years, yet its dim creation rate is multiple times that of the smooth way. The redshift of the world Bell 2744Y1 is 8, showing that its light has been pushed toward our frequencies due to the development of the universe before the disclosure of a 2744Y1. The farthest realized world had a shift of more than 7. However, presently stargazers have found something much further away, cosmic explosion called Demise 16C2 and M, recognized through a dull inertial overview. Supernova are unimaginably huge. blasts addressing the last exertion of a beginning before it kicks the bucket to comprehend how stars work. We should notice their demise. Huge stars consume gigantic measures of atomic materials in their center, which creates a lot of energy. This energy makes pressure that keeps the star from imploding. When you see a star in the night sky, it is since there is a harmony between two contradicting powers. Huge stars have a consistent battle between gravity pulling them internal and the energy delivered by atomic consuming pushing them outward. At the point when the stars clatters out of fuel, it starts to cool and the strain diminishes, permitting gravity to dominate. Furthermore, make start detonate into a supernova. This cycle happens rapidly in a matter of seconds when two stars impact. A cosmic explosion can likewise happen. The death 6C2 cosmic explosion is very interesting and was found in 2016 by a global group of space experts. That star is at type 2 cosmic explosion star, which implies that it has arrived at the finish of its life and has detonated in a calamity blast. The blast is accepted to have happened around 10.5 quite a while back. It has made a trip to us for more than 34s of the history of the universe. Due to the extension of the universe, the cosmic explosion is a lot farther away than it appears to the unaided eye. This 16C2 star was especially intriguing in light of the fact that it was a dim cosmic explosion, which implies that it did not transmit a lot of noticeable light and thusly was challenging to identify. Anyway, recognizing it was conceivable, utilizing telescopes that could see the infrared light produced by the cosmic explosion, the group of researchers associated with the disclosure of Death 6C2 additionally had the assistance of 3 strong telescopes, including the Melian telescope and the Sea Observatory. It required 5 years, and the sky is the limit from there. Then 500 evenings of perception to distinguish this far-off cosmic explosion, which was an extraordinary test. Anyway, the group's exertion were advantageous as the incredible distance of the cosmic explosion will permit them to more readily study and comprehend very radiant supernova and the causes behind this gigantic grandiose blasts. A cosmic explosion blasts of the extent of Death 6C2 or some other Type 2 cosmic explosion would have huge ramifications for the encompassing cosmic system. What's more, possibly in any event for the whole universe. This blast will deliver an gigantic measure of energy, principally in the type of neutrinos and photons, which would collaborate with the encompassing gas. What's more, residue to make a shock wave that would travel outwards at speed of thousands of kilometers each. Subsequent, this SHW would cause the encompassing gas and residue to warm up. It justifies an explosion of radiation that would be discernible acra extensive variety of frequency, including apparent light radio waves and X-beams. Notwithstanding the explosion of radiation, the blast would likewise make weighty components like iron, gold, and platinum, which are fundamentals, building blocks for planets and life. As far as we might be concerned, these weighty components would be scattered into the encompassing universe, improving the gas. Also, dust and giving unrefined components to people in the future of stars and planets. Generally speaking, a Type 2 cosmic explosion blast, like the 16C2 would have broad ramifications for the encompassing universe and would play a significant job in forming the developments of cosmic systems after some time through investigation of the bright light radiated by the SLSN. Researchers can decide the sum of issue delivered and the temperature arrived at in the blast, which is significant to more readily comprehend these occasions. A distinction between that star with VTA Rouge is their sort of cosmic explosion blast. The 6C2 is a sort 2 cosmic explosion which happens when a enormous star runs out of fuel and falls on itself, causing a disastrous blast Viter Rho on the other hand is supposed to ultimately turn into a sort 2 cosmic explosion, yet it is right now named a red super monster, and it is probably going to detonate as a type 2p cosmic explosion, which is a less strong and less disastrous sort of cosmic explosion blasts of the size of Death 16C2NM or some other
Type 2 cosmique explosion.
would have huge ramifications for the encompassing universe and possibly, in any event, for the whole universe. Now specialists are searching for other far-off cosmic explosion and the ones that are probably going to be found in the future. What do you think, Lee, past the